Everyone, my expected source are the friends. I'm going to present my presentation in query performance tuning in database operations. Going through the research paper of four people, I came to know that there is some problem in database tuning process. So concluded from my knowledge base, I concluded this and had presented the PPT regarding how we can do the performance tuning. So let's start. So we all know about the computer system. So computer system generally is a hardware that is composed of multiple resources. Might be RAM, might be hard disks, and other peripherals that works on. So this is a typical, I have presented a laptop, a man working in the laptop, and we can say this is a PC, a personal computer. So, elaborating more, so computer system encompasses hardware, software and networks that works together to perform the various tasks. The computer has been invented for the human comfort. Next, I have a place. This includes components like central processing unit, CPU, memory, storage devices, operating systems, applications, and the communication networks that I just already have said it. Going further, the system contains memory, and we know all about the memory, right? So in this figure, I have a present that the hierarchy of the memory and its cost. We all have been going through the computer systems containing the memory from smaller to the faster and more expensive. Since CPU registers are directly associated in the BIOS, so they are more expensive, and then the cache. The size decreases as we move upward, and the space gets more and more big when we move downward or we move towards secondary storage. So, saying this, in computer system, memory refers to the physical devices or the addressable locations used to store data temporarily, not permanently, because we are not going through the secondary storage right now. Every transactions are performed in the primary memory. So the primary memory is small in size and it consists more expensive in nature. For the short or the long durations that enable efficient and fast access by the computer processor, so we are directly related with the registers and the cache memory for faster operations and faster user experience. Going further, memory is a crucial component, we all know that, and it plays a key role in the execution of the program and on the overall performance of the computer system, since it is related with the performance of the computer. And now the tolerance of the human is less than even 3 seconds in current days when we browse through the networks. So the computer should be more faster than that. So obviously my topic is query performance tuning, and it is related with the database. So what is database? Database, does this figure describe the database? Saying the database gives us some level of conceptualizations of storing informations, either that may be in the row or in column format. We may have gone through the Excels, and Microsoft Access even is a relational database management system where we keep our data in relational basis. So moving forward, database is a vital element in the technological driven world, empowering the vast application. Every application consists of the database right now. In past days, in the early period of development of technologies or even the websites, we have been going through the static pages where there is no interactions of the database. But now, every applications, even mobile applications or website, whatever be the applications, it consists of a database. And the database is for dynamic, or you may say a content management system that can be changed at any moment of the time. Right. Moving on, starting from the RDBMS. RDBMS, Relational Database Management System. So it is used on the basis of relations for creating the inventory related transactions. We may seek information from sales related and customer related, where the normalization is done in many forms. Moving towards from the database RDBMS, let's move to the ODBMS, Object Based Database Model System, streamlining the complex data interactions like CAD, computer aided system that designs our infrastructures or the buildings or for the office automations. And moving further, we have been now in NoSQL, where there is no vision of columns, rows, or we may say that unstructured data, where the sourcing has been very, very difficult, or where the tuning process is very difficult. So, what is query now? The performance is directly related with the writing the queries, and the process of query is extracting the information from the database as per need. So in the context of database, a query is a request for information or an action performed on the database using a specific query language. Might be a SQL, we might be using PHP we can also use the SQL. Structured query language, SQL stands for. And it is very easy for the developer to write the query. So the purpose of the query is to retrieve, manipulate, or update the data stored in the database. The main purpose of writing query is for retrieval of informations. Behind that, for the updation of the database or the informations in the database for the physically or for long periods. And the ability to write the effective queries is like a skill for the database administrator, developers, or anyone working in the database areas. So this is a very challenging situations of writing the queries more effectively. And here we come, query process. So how does query works in actual scenario? Let's look into the figure. So here, whenever we place a high level query, it goes through the parser and translator. Then a relational algebraic expression is created. Well, the optimizations from the statistics about the data has been accumulated. Then execution plan is created. So execution plan is directly related with its optimization, its cost, and many other things. Evaluation engine in the database system evaluates the query that has been optimized or generated from the relational algebra, and then we just execute it from the database management system, and we get the output as per our results. So where is the issue now? Going through the research paper, I came to the issues in this mode. The performance area and the issues are basically in the application, the major portion of the application. This is the application, this is the major portion of where we face the query tuning, and the problem arises here. Besides this, the other content is a design. This design holds certain percentage, and database itself, and then the OS, this portion. So OS only deals with very little amount of the issues. Might be the storage issue, might be the RAM issues. The conditions might create there. Before jumping, I already said that in today's world, every application is database driven. It's a CMS, content management system right now, every application is. So we have been facing lots of the issues in this area rather than any other. The major issue is in application level. As for the research that I have gone through, so query performance issues. The first task in the database tuning is to understand the cause of the problem. Without that, we cannot proceed, or we cannot find out what is the major cause that is causing the performance issue, or what is creating the barrier in retrieving the information in late scenarios, and finding the bottlenecks, CPU bottlenecks. Let's come to the infrastructure, CPU bottlenecks. So these occur for the different reasons like having non-optional query plan. When we are talking about the query, the obtained value after the algebraic expressions that we obtain and the optimizers have been merged, if the plan are not properly executed, if the plan we got from the database management section is not properly designed or not properly configured, then we obviously go through the CPU bottleneck. So this a plan inadequate applications, database design, poor SQL server configurations, and the lack of the hardware resources is the cause of CPU bottlenecks. Besides this, we have the other portions, memory structures. We already said that the primary memory is the main memory where all the tasks are concluded or is done. So the primary memory is limited, and on those basis, the performance gets under issues. So memory affects the performance more than any other piece of the hardware. So it is necessary to monitor the memory usage, which the DBA does. Database administrator does. The main role of the DBA is to monitor the memory usage in the regular mode on SQL Server system to ensure that the percentage of memory available is higher than 20%. So what does this mean? This means if there is less than 20% of memory in the configured system, then we are going into the database query performance issue. We face query performance issue. So this needs to be adjusted by the administrator of database or the network administrator who knows some level of database ideas. So moving on forward, the other is database design issues. We can think about the database or simple applications that consist of few tables structures. In current scenarios, we have been creating the normalizing process, and during this process, we create lot of tables that are not necessary, might be not necessary. We might have thought for the future works, but for the current scenario, that might not be fruitful. So we should understand the database design, how we can go through the applications. So in the early phase of development, though we figure out the complete structure, there might exist issues in normalizations, indexings, and many more. The other is indexing issues. Indexing helps us in retrieving the data frequently. After indexing, the performance of the query is higher, but still, if a simple table have multiple indexes, then we fall into the performance issue, because the CPU needs to allocate out of the database system, needs to perform extra overhead tasks for keeping the indexes up to date. This is the cause of the database performance issue. Moving on, inefficient query. So inefficient query, we generally see the query containing in where clause. So how does we write that? We just write select asterisk from this table where name in bracket open and all the parameters we put in the apostrophe options. So if we go through that, the query optimizer needs to break every label of the parameter that is supplied into the in function into the granular level. So that is also the headache of database administrator, or even the database engine needs to break those components into the smaller chunk and do the performance and execute the query plan accordingly. So we should be aware of using in operator in more conscious manner. So query performance. What is query performance now? How we can do it? For what we need to do query performance? These are the major questions. Going on. Optimizing query ensures that the data retrieval and the manipulation operations are executed in the most efficient manner that yield high performance. Since database contains the lots of the information in normalized form or unnormalized, denormalized form, but the main purpose of query performance is to retrieve the information at very short period of time. But a big challenge is how we can achieve the optimization. This is the biggest challenge, and in today's areas of development, our developer team members are stuck in this, in writing efficient queries. The use of improper syntax that delivers the query performance issues, and we are going into it. So how do we do understand? We need to first understand the data models. What are our data structures? Might be a varchar. We might store the text in varchar. A number, even number we can store in the varchar, variable character, varchar. But a number should be always stored in integer form. Integer are of two types: 64-bit, 32-bit. What is the level of integer? We should go through the data models. We should understand the applications and its database systems, how we can handle efficiently. So, having a solid understanding of the database schema and data models, knowing the relationship between the tables and cardinality of relationship and the distribution of the data will help in crafting the efficient queries. In current scenario, the developer are losing this context. They just write the codes and they test in the local machines where they have the allocated high resources like a high 16 GB RAM or even SSD we can have in our PCs where the local development is done. But when we deploy it into the client mode or into the network, then we fall into the performance issues. The major cause is not understanding the data models. The other is use of index. Creating a multiple index in the same table, we already discussed that creating a multiple index in the same table creates a barrier, creates an overhead to the database system in retrieving the informations. So, while creating the indexes, we should be very conscious. Index helps in speed up the data retrieval by providing a quick lookup mechanisms. Creating indexes on the column frequently used in where clause, joining conditions, and order by clauses helps in performance tuning as well. Helps in writing efficient queries, but we should know about it, where to implement the indexes. How many indexes needs to be implemented in the database tables. Other, avoid select distinct. We write the code like select distinct name is the, let's assume that name is the column name. Select distinct name from table employee. If distinct gives the unique value, but the relational algebra that the query performance the database system creates is very huge, because it needs to sort out, it needs to compare each. So beside doing this, we can do in different methods. Select name from this table, group by, or having the clause can be used for the performance tuning. Here, the distinct keyword is a resource intensive. Consider alternative approach to eliminate the update duplicate rows. Distinct definitely gives the unique rows, but it is a resource intensive. So we need to optimize this. And how we can do it? We can do it by group by clause. So other is use of aggregate functions wisely. Aggregate function means mean, max, sum, average, those calculations. So the algebraic calculations that is done in the database system. For the calculations, we may go through the inventory management system database as well, where the columns contains other rows contains the sales table. The multiplications of there might be the multiplications of quantity and the rate. and we do not store those values as an amount in alternative columns. We just do that calculations the funny. We obtain the values from the DB and then proceed it in the funny for the sake of fast. But when we retrieve the data from the database, and if the calculation needs to be done again in the application level, then we are getting to the performance issues, because we need to recalculate it again. So aggregate functions like sum, count, average can be conceptually expensive, because lots of the data in the big data concept, lots of the data needs to be accumulated, and do the algebraic expressions needs to be implemented for the output of the result. Use them judiciously and consider pre-aggregating data where possible. So in the concept of the big data, we should neglect this type of aggregate functions so that the tuning can be more effective. Limited use of joins. In today's world, we do create normalizations of tables, even though we don't need it in future. But we have a reason that normalization helps in retrieving the queries in faster mode. But joining multiple tables can create barrier. So we should avoid the multiple tables joins, and what the resource says. Here, while joining operations are essential for combining data or obtaining the data from the multiple tables, excessive use of can impact the performance. Redesign the structure if any operation requires 5 or more table joins. The 5 or more table joins means normalizations. The normalizations means the granular level of data that we collect from the user, which may or may not be used in the future. So, if we are joining multiple tables, the tables more than 5, then we need to reconstruct our database system for the sake of faster operation of the query. The other is denormalizations. In some contexts, we may not need the normalized data while keeping the address of the person. We may do not or may not require the multiple level of tables. There might be a permanent address and secondary address, temporary address. As per the constitution, we might go through the Pradesh. That might not be required. But in the current scenario, we have been creating that. And that is the normalizations. While we create joins for retrieving the informations from above statements, we require multiple tables. That might be more than 5. So, denormalizations also sometimes helps in query performance tuning. So, this can be obtained by the discussions with the client, whether they need or not. What is their need in the granular level? In certain scenarios, denormalizing the database by introducing redundant data can improve the query performance. Bhaktapur can be multiple times in the database. If we normalize it, Bhaktapur can be kept in one place and its relations can be imposed into the multiple tables. But creating that is creating us the performance issues, since we need to join multiple tables. So here, this trade-off is often made in the data warehousing and reporting scenarios where read performance is crucial. So denormalizations helps in retrieving the information faster, where there are lots of the data, where we do not need normalizing. So moving on, considering cache, it's the hardware related, cache memory. The frequently asked queries if we can cache it, or the results if we can cache it in banking sector like. The query that is fired from the user has been tracked. Its result is being tracked. So that the second user, if fires the same query, then the result gets faster in the user age. So we should maintain the cache. caching. Implementing caching mechanism to store and reuse frequently accessed query results helps in performance tuning of database. Caching can significantly reduce the load on the database, as we have already retrieved the information from the database system and stored in some other tables, false table, and the same query gets fired again, then the false table can help us in giving the sets of data within a fraction of seconds, and this helps in optimizing, especially for the queries that do not change frequently. In banking case or in a normal case, we have to maintain this. And the partition. Partition means in the case of big data. Where the data are big and we fire the certain level of query, then the process is getting very tedious, or the process is time consuming. So we need to partition the data. Partition means the data means we need to dump the certain level of data. We need to segregate the unused data from the system, or we need to create a different database that is only used for the reporting purpose. So the active database needs to be always light, and for that we need to partitioning. We need to shrink the database. When we work in database system, its log files gets heavily increased due to the manipulations, due to the CRUD operations. If you go through, it's a create, U, update, D, delete, and R read. Though read doesn't help in growing the database, but the other three parameters, read and write functions, obviously grows the database. It's log. If the log is heavy, then the query is getting slower. So we need to shrink the database. The partition is the same thing. For the large tables, consider partitioning database to improve query performance. Partitioning involves dividing the large tables into the smaller, more manageable pieces. So the working database should be always in light version, so that the query execution gets faster. For the management, we need the previous data. For the operator level users, we don't need the last year data, probably a 5 years back data. So for the time being, we need to segregate them, and it makes the database light. The other, monitoring and analyzing the query performance, the main JD or the main role of database administrator. He needs to monitor and analyze the query that has been fired from the applications. He needs to analyze what is causing the barrier in retrieving the information. Regularly monitoring query performance using database profiling tools. It's an inbuilt tool of MS SQL, Microsoft SQL, which helps in analyzing the query performance. And it suggests few suggestions that can help in improving the query performance. Identifying slow performing queries, analyze their execution plans, and making an adjustment as per needed. Microsoft SQL has a feature of profiling, which executes the query and suggests the optimal solution for the query so that it can be faster. And writing absent queries, we came here again. Crafting queries that retrieve only the necessary data. Use of select statement to fetch only the columns needed. We generally fire, as a developer, being a developer or as a developer, we generally fire the statement like select asterisk from this table. Asterisk means collecting all the columns, whatever is needed or not needed. If there are 16 columns in a table, then all the columns are being extracted in the user, but that might not be needed for the purpose of the user. So we should verify the column name. In select this column, we might implement where clause as well for getting the specific data, which might be useful, but in management case that might not be useful. If I need the data report based on the 5 years back, then I will fire all the columns name mentioning all the columns name, but the where clause might not be there. So why do we need to write the queries in efficient manner? Why do we need to tune the query? Obviously for the performance, but for what? In today's scenario, everything has been changed. We have been hosting in the servers, and it costs financial problem. The concept of Amazon, AWS, web service. You can think about it. Pay per use, the concept. We can go on. So let's have it. So query performance tuning in the database is essential for several reasons, and it plays a crucial role in maintaining a responsive and effective database system. We already discussed about it. But why do we need it? The first factor, improve user experience. If the user is getting his results after a minute, then he is complaining about the system. That needs to be pulled down. The tolerance of the user in the current scenario is not more than 3 seconds. And our query should be such efficient that it should give the result below the 3 seconds. The next, reduce resource consumptions. The concept of AWS or the pay per use comes here. The concept of AWS is just hosting, not hosting the database or getting the price and sum of the amount by hosting. The concept is what you use, how much RAM you consume, how much hard disk you consume, how much are in granular level you can say how much select statement did you file, or how much update statement or delete statement you have been filing from the application level. The cost is calculated on those basis in current scenarios. So pay per use, the AWS concept comes here. The next, obviously, cost optimizations. If we write the efficient queries as per said in the previous slides, that will drastically decrease the cost. It will optimize the cost because the queries are so efficient. It might need a little amount of RAM or the little amount of storage if the queries are efficient, written in an efficient manner. So cost optimization is another factor for which we need to do query optimizations. Besides that, maintaining data integrity. Data integrity means what? Maintaining consistency throughout the applications. If we maintain the efficient queries, if we write the efficient queries, then there is no chance of being mismatched. If we maintain proper indexes, if we make proper joins, if we use proper functions, and if we avoid select asterisk from the table name, or if we avoid select asterisk from this table where in and the bracket the parameters, that will maintain in helping the database integrity. So in conclusion, in summary, query performance tuning is a proactive measures to ensure the optimal database performance, scalability, and resource efficiency. Query performance tuning is all related with the database, its performance, scalability, and resource efficiency. Means the proper utilization of the resources on need basis, on requirement of the query. The other, it is essential for meeting the user expectation in a low amount of time. Faster query performance or result-giving queries are entertained. Controlling the cost, we already discussed the concept of AWS or pay per use, and supporting the growth and stability of the database system. That is the partition, keeping the light database helps in performance query tuning. So I conclude my slides over here. If you have any queries, please let me know.
तपाईँ रिभ्यू गर्नुहोस्। डाइरेक्ट यो डाटाबेसमा चाहिँ होइन आजकल चाहिँ मतलब जुन बिग डाटाहरू चाहिँ कुन फर्मेटमा राखिरहेको हुन्छ जस्तो एसक्युएलहरू मात्रै हुन्छ कि
Having said that, in today's scenario, we have been going to the NoSQL where it's unstructured, the big data, and it's a big challenge in performance tuning over there because NoSQL or even we may say unstructured data have been facing query performance issues. For the sake of query performance issues neutralizations or getting it down, we have been maintaining SQL database or MySQL database, whatever the database that has a structure, as it gives the query performance higher. The rate of performance is higher over there because we can do indexings, we can use the joins, we can use the average functions of the aggregate functions, we can use the select statements with the minimal parameters, but in the case of unstructured data, that is not possible. So, the concept of big data has been rise from there. Since all the things, all the contributions to our have been given to us as structured data.
अनि त्यो ODBMS त्यो भनेको चाहिँ एकचोटि फेरि
So moving to the slide number, I guess 2.
अलिकति with examples.
It's all about the automation system. OBDBMS. In current scenario, we have been doing AutoCAD engineering for the engineering tasks, CAD systems or office automation systems. I guess over here in database, yes. It's a computer-aided design AutoCAD system, which gives us the scenario on the basis the user wants to design. The ODBMS directly deals with such type of database. It has 3D modeling approach. There is a pre-design of the building where we pull out the designs, place in the working placement, and then draw our as per need. We may segregate the rooms as per our need. So 3D modeling is the concept of ODBMS.
You have mentioned many ways to enhance the performance, but is there any kind of algorithms which is famous to us?
Till now, such algorithms have not been discovered or not have been analyzed or discussed in the review paper that I have gone through. But obviously, there might exist the algorithms because all the things in the database have been algorithm driven. We are talking about the query structures, I guess, in the slide number 4 or 5 here, over here in the slide number 5. Everything we do, we process, we just write the high level queries over here, and the system parses it, generates the relational algebra where it enhances with the statistics about schemas, implements the schemas, and gives us the execution plan. It is all generated by the algorithms. And the relational algebra, there exists some level of algorithms. So definitely there is the use of algorithms, but in maximum case we have not been discussed on it. Even in the research paper it has not been discussed. So definitely there exists an algorithm that needs to be found out and discussed on
it. In this figure, which is the most important part to observe by the developers to interact with database?
So, developer, the main role of developer is to develop the applications. And for development of the application, he should know about the database structures. After knowing only the database structures, he can write efficient queries. So, the major portion where the developers need to focus is this query level. Or we may say this data level. After knowing the database structure, it normalizes the concept of normalizations and the structure indexes in the tables that has been created. Only we can write the efficient queries. So Primary, we should go through the database study, database modeling, then we need to write the efficient queries.
ओके सर अब के दिनुपर्छ
केही छ मैले सोध्न मन लागेको मोस्ट अफ द मैले सोध्न खोजेको क्वेसन सार्वजनिक स्टोरीहरू सो नोएसक्युएलको पर्फर्मेन्स चाहिँ रिलेसनभन्दा कम्प्लेक्स हुन्छ भन्ने हो कि पर्फर्मेन्स इस्यु के हो भन्नु भन्नुभएको थियो
पर्फर्मेन्स इस्यु चाहिँ नि तपाईँको के हो भन्दाखेरि अनस्ट्रक्चर्ड डाटाहरूमा सर्टिङ गर्नलाई चाहिँ हामीलाई प्रब्लम
हुन्छ जस्तो लाग्यो
हजुर
त्यो हो भने अहिले मोस्ट अफ द बिग डेटा छ
हजुर
नोएसक्युएलकै युज गर्छ
अहिलेको कन्सेप्टमा चाहिँ त्यो हो किन भन्दाखेरि स्ट्रक्चर डाटाबेसमा गर्ने जति सबै सकिसक्यो अब रिपोर्टिङको पोर्सनलाई मात्र हो तर एप्लिकेसन लेभलमा
मोर बिग डेटा चाहिँ नोएसक्युएलको रिप्रेजेन्ट गरेर त क्वेरी त झन्डै खतम हुने हुने
अभियसली किन त्यो सर्चिङ प्यारामिटरहरू मिल्दैन तपाईँको स्ट्रक्चरमा जुन हामीले चाहिँ जोइन्ट्सहरू लगाउँछौँ त्यो जोइन्ट लगाउनु मिलेन ट्याबुलर फर्ममा भएन इन्डेक्सिङ गर्न मिलेन भनेपछि त्यो नो एसक्युएलमा या चाहिँ भनौँ न एउटा टेक्स्टमा लेखेको डाटालाई इमेलै हेरौँ हामीले इमेलमा भएको कन्टेन्टलाई हामीले के गर्छौँ स्ट्रिम राइटरमा ल्याउँछौँ सबै राइट अब मलाई चाहिँ के छ भने इमेल दिस इज दिस भनेर लेखेको होला तर मलाई के चाहिएको छ भन्दा त्यो इमेलमा दिस कतिचोटि युज भएको छ भन्नलाई त मैले कलेक्सन अफ डाटालाई चाहिँ स्ट्रिम अफ डाटालाई चाहिँ मैले मेमोरीमा राख्छु होला देन आई साइकल इन लुप कतिचोटि काउन्ट भएको छ त म्याच कतिचोटि भएको छ त्यो गर्छु होला यसले चाहिँ के गरेर चाहिँ पर्फर्मेन्स हिट गरिरहेछ भनेपछि लो क्वेरी ट्युनिङ भइरहेछ किन म्याच गर्नु पऱ्यो एभ्री क्यारेक्टरलाई म्याच गर्नु पऱ्यो यदि त्यही चिज चाहिँ हामीले चाहिँ स्ट्रक्चर डाटामा राख्थ्यौँ भने वान सर्टमा फायर गरेर हामीले निकाल्न सक्थ्यौँ वेयर क्लजमा राखेर गर्न सक्थ्यौँ तर यसमा वेयर क्लजमा राखेर गर्न अलिकति अप्ठ्यारो छ
मैले यो कुरा बुझेँ मैले भन्न खोजेको के हो त जति ठुलो डेटा छ अझै पनि हामीले पर्फर्मेन्समा प्रब्लम भइरहेछ भने नोएसक्युएल किन त्यति प्रब्लम युज भइरहेछ
झन् पर्फर्मेन्स
ट्युनिङ गाह्रो छ भन्ने किसिमले आयो
त्यो चाहिँ नि त्यसलाई मैले एक्सप्लेन गरिरहनु पर्दाखेरि एभ्री अघि मैले भनिहालेँ हाम्रो टेबुलर स्ट्रक्चरमा रोज एन्ड कोलम्स हुन्छ होइन रोज एन्ड कोलम हुँदाखेरि हामीले कोलम क्रिएट गर्दाखेरि सर्टेन जस्तै इन्टिजर क्रिएट गऱ्यो भने 16 बिटको हो कि 8 बिटको हो कि त्यो क्रिएट गर्नु त्यसले सर्टेन साइज खान्छ हो क्यारेक्टर भ्यारक्यार राख्छौँ होइन भेरिएबल क्यारेक्टर राख्छौँ त्यो भनेको कति हुनसक्छ 250 हुनसक्छ 10 हुनसक्छ 20 हुनसक्छ इभन डाटा भएन भने पनि त्यसले मिनिमम त्यसको लेन्थ अनुसारको मिनिमम मेमोरी त कन्ज्युम गर्छ नि स्पेस कन्ज्युम गर्छ नि त तर टेक्स्चुअल फर्ममा भयो भने त त्यो स्पेस कम हुन्छ ड्रास्टिकली कम हुन्छ भन्ने कुरा भएको हुँदा नो एसक्युएलको चाहिँ कुरा आएको
स्टोरेजको केसले
एउटा चाहिँ मेजर फ्याक्टर स्टोरेजको केसले हुनुपर्छ
जस्तो स्टोरेजकै केसमा हुन्छ जस्तो डिनर्मलाइज डेटामा चाहिँ एफिसियन्ट क्वेरी हुनसक्छ भन्ने कुरा पनि होइन किनभने डिनर्मलाइज हुन्छ भने त डेटा रिडन्डेन्सी हुन्छ अभियसली यसले पनि त फेरि स्टोरेज बढीले
लिन्छ
रिडन्डेन्सी भयो भने त्यो त्यस्तो केसेस भयो भने र नोएसक्युएल कम्पेयर गऱ्यो भने स्टोरेज कुनले बढी लिएला
त्यो भयो भने चाहिँ डेफिनेटली तपाईँको चाहिँ नि जुन डिनर्मलाइजेसन गरेको छ त्यसले गर्छ तर डिनर्मलाइजेसन कतिखेर भन्ने कुरा पनि छ त्यहाँ डिनर्मलाइजेसन चाहिँ यदि मैले मल्टिपल भक्तपुर एक ठाउँमा मात्र राखेर मल्टिपलको भक्तपुरको आइडी मात्र पास अन गर्ने हो भने त्यो केसमा डिनर्मलाइजेसनको चाहिँ युज गरेको बेटर भन्ने कुरा हो होइन तर अब भक्तपुर सबै ठाउँमा राख्यो भने त स्पेस खायो नि त आइडी पास गऱ्यो भने इन्टिजर भ्यालु गयो त्यो 8 बिटको होला भनेपछि त्यसले सर्टेन लिमिट त क्यारेक्टरभन्दा त कम पायो तर के भन्दाखेरि 5वटा भन्दा बेसी टेबल लगाएर हामीले जब जोइन्ट क्वेरी लेख्छौँ त्यसले चाहिँ पर्फर्मेन्समा हिट गर्छ त्यो भएर चाहिँ डिनर्मलाइजेसन नगर्ने हो कि नचाहिने केसमा मात्र भन्न खोजेको
अब अहिलेसम्म हामीले अब एब्स्ट्राक्टली कन्क्लुड गर्ने भने कुनै अब आरडिबिएमएसको भर्जन नोएसक्युएल सुपेरियर भनेर पाइएन रिभर्स गर्न पनि पाइएन यो दुइटैको केही न केही बेनिफिट होला केही न केही चाहिँ
ड्रब्याक्स अभियसली हुन्छ भयो
सुपेरियर अब जस आज तपाईँले अब हेरेको लुपेबल मात्रै हेर्नु भएको पनि त्यसको आधारमा भन्दाखेरि पनि एउटाको ओभरमा अर्को सुपेरियर छ भन्न चाहिँ पाइएन पोजिटिभ छ नेगेटिभ छ भन्ने
अब यसलाई चाहिँ मैले कसरी ट्युन गर्छु भन्दाखेरि तपाईँको निड के हो मैले भने एप्लिकेसन बनाउँछौँ हामी तर मलाई त्यो ग्रानुलर लेभलकै डाटा मलाई चाहिएको छैन भने युजरलाई चाहिएको छैन मैले किन नर्मलाइजेसन बेसी गर्ने यदि युजरलाई पछि जाँदाखेरि चाहिँ त्यस्तो भास्ट रिपोर्टिङ छैन जहाँ चाहिँ मैले सर्च अल्गोरिदम्सहरू डेभलप गर्नु पर्दैन, जहाँ चाहिँ क्वेरी अप्टिमाइजेसनका कुराहरू धेरै हेर्नु पर्दैन भने मैले चाहिँ टेक्स्चुअल फाइलमा डाटाहरू राख्छु। पहिला हामीले जुन बेला जब डाटाबेस आउनुभन्दा अगाडि गरिएको थियो होइन, डेबुकहरू मेन्टेन गरिएको थियो। डेबुकमा पनि पहिला हेऱ्यो भने त एबिसिडी अल्फाबेटिकल अर्डर थिएन नि, यस्तो जस्तो पेपर कपी जस्तो थियो, त्यसमा हामीले लेख्दै जान्थ्यौँ। पछि पो त सर्टिङ गरेर एबिसिडी जेडसम्म आएको हो। भनेपछि हाम्रो निड के त, हामीलाई केमा राख्दा सजिलो छ त्यो चाहिँ आइडेन्टिफाइड हुनु पऱ्यो।
के छ साथीहरू, सो अब जनरल ओभरअल फिडब्याकमा नाइसली प्रेजेन्टेड होइन, क्लियर छ एकदम। तपाईँले जे प्रेजेन्ट गर्नु भएको छ एकदम क्लियर छ है, स्लाइडहरू ठिक छ। हामीले पहिला अझै जस्तो त्यस्तो डिस्ट्र्याक्ट गर्ने खालको केही छैन, क्लियर छ, सिम्पलमा छ। थ्याङ्क यू भेरी मच, ओभरअल नाइसली प्रेजेन्टेड।
Thank you everyone for listening me for the I guess 15 to 20 minutes or more.
45 minutes.
Oh, 45 minutes. Oh, it's a long presentation. I just got
आज एउटा मात्रै 45 मिनट चाहिँ
only 17 or 18 slides I have. But it has been long. It might have been taken in during explanation. So thank you all everyone.